Alright, in this video we're going to be taking a quick look at trig sub, just as a quick introduction. So what is trig substitution? Well, you can probably imagine it's a kind of substitution that you'll do in an integral, just like u substitution. It's just a different way of doing a substitution. Fortunately, it looks a lot like a u substitution, so there really isn't too much to go over. But here's the bottom line. I've written down these couple formulas. I'm going to switch this color to an easier one real fast. I've written down these three Pythagorean identities. These three identities are going to be what guide your trig subs. So what is trig sub? Well, if I have an integral of, let's just say, the square root of 1 minus x squared. Well, right now you have no way of doing this, but you'll start to realize that a lot of your integrals will look kind of like trig identities. For example, if I take this identity over here and I subtract sine squared x from both sides and then square root, then you'll notice that this basically looks like what we have in our integral. So the point is, when you see 1 minus x squared or something minus x squared or square roots, that's your sign to use trig sub. And the substitution that you use will be exactly what's in the trig identity. So for this integral, if I let x equal the sine of my new variable, let's call it theta. What I want you to notice is that the integral that you get out of it, I can find what dx is right away. Dx is cosine theta d theta. And the integral that I get is the square root of 1 minus sine squared, which we know is cosine. I had a 2 here by accident. I got to take it away because I took a square root. Square root of 1 minus x squared is cosine x. When I plug in sine theta into there, I get 1 minus sine squared theta is cosine squared theta, and then I square root it and I get cosine theta, and then dx I just turn into cosine theta d theta. Okay, so, and this, you can do this with all kinds of other integrals. This is just an intro video. I keep these short, so I'll just introduce when you want to use these and just give you a very vague idea of what's going on. Right here, I see a 1 plus x squared, so I see that this identity looks a lot like that. So I will let x be tangent of my new variable. Once I plug this into here, I get 1 plus tangent squared, which is secant squared. That's my identity. Square root of that is secant, so everything goes away. And I won't simplify past that. I'm just trying to give you a very, very rough idea. How about x squared minus 1 to the 3 halves? Well, this one actually looks like the middle identity if I subtract off the minus 1 off here. So if I subtract 1 on both sides, I'll get tangent squared x equals secant squared x minus 1. And so if I let x equals secant theta, then this inside turns into secant squared minus 1 theta, which is tangent squared theta. And then tangent squared, things will cancel and they'll end up nicely. So that's just a quick overview of what's going on here. In the next couple of videos, we'll do a ton of examples, and I'll see you